Right, so now we're going to move on to section C, and it's the last section of this chapter, and that is scientific notation. All right, remember, there are always these questions that we need to worry about, focus on, try to answer in more detail and more complete as we move on through this unit and through this section. So we just want to make sure that we're constantly focusing on these, and that is, why should we have different ways of writing large numbers? All right, so that's what we're worried about today. That's what we're focused on today, and that's where scientific notation comes into play. It does help us with writing these very large numbers or very small numbers. It works with either way. All right, so very large numbers or very small numbers. All right, so the first thing I want to do is to start out by writing out some of our multiples of 10. So if we do 10 to the 0, as we learned before, anything raised to 0 power is 1. If we do 10 to the first, that's equal to 10. If we do 10 squared, that's equal to 100. If we do 10 cubed, that is equal to 1,000. If we do 10 to the fourth, that's equal to 10,000, etc. Right? Essentially, what we're doing here in each step is we're multiplying each one by 10, and we're just re-raising our power by another 10. That's why we're getting from 0 to the first, to the second, third, fourth, and so on if we want to continue this. Also, I wanted to just point it out to you as well, is that if you notice, every single power that we have is also how many zeros we have. So if you forget how we're raising 10 to a certain power as quickly as we are, you can just think about the power that we have helps us with determining, as long as it's positive, it helps us in determining how many zeros we have as part of our number. All right, so I just want to go through why this is useful and how this helps with our scientific notation. So once again, if I give you 10 to the fourth power and I ask you what this is, based on what we did over here and based on what I was just saying, is we know that this 10 to the fourth power is equal to 10,000, because we know when it's raised to a positive power, the number of zeros that we have with our 10 is simply the number of power that we have. Now, what if I asked you before, what is 5 times 10 to the fourth power? Instead of me just saying 10 to the fourth, if I ask you, what is 5 times 10 to the fourth? Well, we know that 10 to the fourth is equal to 10,000, so this is the same as 5 times 10,000, or 50,000. So this here, this 5 times 10 to the fourth, is actually the scientific notation of 50,000. So it allows for us to take this larger number and to rewrite it in something that's easier for us to work with and just a smaller number. All right, one of the things that we have to be aware of, though, is this number 5. All right, this number that we're multiplying by our 10 raised to a power, that number, we're going to represent it by the letter A for right now. That number needs to be greater than or equal to 1 or less than 10. So what that means is that the number that's here cannot be 2 digits, right? Or it cannot be. It cannot be a number. We can't have 2 digits, 2 whole digits, meaning we can't have 2 digits before the decimal value. All right, I'm going to go through an example in just 1 second with what I mean by that. But that first number has to be greater than or equal to 1 or less than 10. So it cannot be 10. It cannot be a number that is 2 digits long as far as with the decimal place coming after it. So we cannot have a 10. We cannot have a 20, a 30, a 100, a 1,000 or anything. This number needs to be a 1, and then we can have decimals after it. All right, so let me go through what I was talking about with that. So first, let's say that you're dealing with a problem in science and we're working on how far the sun is away from our Earth. And that is roughly 93 million miles away. Right, so if you were going to be doing calculations with this or multiplications or anything with this number, it's a fairly large number. And we're going to plug this in our calculator and we actually do multiplications. Our calculators don't have that many decimal values that we can show, so it won't show you everything that's going on there. It'll actually rewrite it for you in scientific notation, or it might leave out some of the decimals. So we want to rewrite this in a way that's easier for us to rewrite and easier for us to work with. Because if we were constantly showing our work and we're writing this 93 million like this every single time, or we're typing into a calculator, it's easy for us that we could possibly make some mistakes because there's a lot of digits going on there. All right, so we just want to rewrite this in a way that's a little bit easier. So based on what we did here, one of the things that we could see is we had 4 zeros as part of that 50,000, and that 50,000 ended up being raised at 10 to the fourth power. So we can start by doing that and say that we have 6 zeros here. So we can say, well, this must be 93 times 10 to the 6th power. However, remember what I said here, that first digit has to be greater than or equal to 1 or less than 10. And 93 is greater than 10. So we need to rewrite this one more way. So this decimal place is understood to be over here. So we actually need to rewrite this as 9.3 so that this first digit is either greater than or equal to 1 or less than 10, which is what it is now. But since we rewrote this 93 as 9.3, we need to now change this 10 to the 6th power, all right? And we know that this has to be, if we wanted to do 9.3 times 10, that would give us the 93. So that shows what we need to multiply to get back to that 93. And as we were looking here, every time we multiply by a number by 10, our power increased by 1. So this actually becomes 9.3 times 10 to the 7th. All right, so that's one of the ways that you can do this. Another way that I'm just going to show you here now, which is just really quick and it's really easy, but I just kind of wanted to go through this explanation, is you locate your decimal point. And here's your decimal here. And if we're trying to make a large number smaller for us to work with, then we're going to go ahead and count how many decimal places we need to move it. So 1, 2, 3, 4, 5, 6, 7. So that tells us that we will be multiplying by 10 to the 7th power. And then whatever that number is after we move the decimal place, that is what we will write here. So it's 9.3 times 10 to the 7th. All right, so that is making a very large number smaller. There's other types of numbers that we can do this with. And let's say we are working with, all right, so we don't only just use this when we don't only just use scientific notation when we're dealing with very large numbers. We also use it when we're dealing with very small numbers. Let's say I give you the number 0.00008. All right, this is a hard number to work with as is. Once again, you can easily mistype in your calculator with having this many zeros, and we just want to work with it in a better form. So when we were making a very large number smaller for us to work with, we just took this decimal place and we moved it however many spaces we needed in order to get that first number to be greater than or equal to 1 or less than 10. And then depending on how many spaces we moved, we multiplied that by the positive power. So when we're doing the negative, we're just doing the reverse. So we're going to move this decimal place until we have a number that is greater than or equal to 1 or less than 10 as our ones place. So 1, 2, 3, 4. Now this will leave us at 0.8, so we need to move it one more time. So that would then give us 8. And we moved it 1, 2, 3, 4, 5 spaces. So this we need to do 8 times 10, but now it's going to be to the negative 5th power because this number 8 is larger than the number that we actually started with, 0.0008. So we need to actually write this so that if we were to multiply these two together, that it will make it a very small number. And we know that this works because just like the pattern that we did in the beginning, if we start with 10 to the 0, if we do 10 to the negative first, that's equal to 1 over 10, or that's equal to 0.1. If we do 10 to the negative second, that's equal to 1 over 10 squared, which is then equal to 1 over 100, or 0.01. 10 to the negative third, that's going to be equal to 0.001. 10 to the negative fourth is going to be equal to 0.0001, and so on. So as our powers are decreasing with value, this decimal place, because this is equal to 1, this decimal place is moving to the left that many spaces. So it went from 1 to negative 1, so we moved it one space over. Went from negative 1 to negative 2, we moved it one space over to get that 0. Negative 2 to negative 3, we moved it one more space over to get another 0, and so on. So whenever we are multiplying, and if you notice all these digits from this 10, they are moving however many decimal places here, or however many, whatever the power is, that's how many decimal places we're moving from that original 10 to the 0. So if we wanted to figure out what 10 to the negative 5th power is, we can start with 10 to the 0 is equal to 1, and we can then just move this decimal place over 1, 2, 3, 4, 5 spaces, and that would tell us what our value is actually equal to. All right, so that's why when we're making this smaller number larger like we're doing here, in order to get back to the original number that we started with, we need to be multiplying it to a negative power. All right, so if we're making a larger number smaller, we need to multiply it by a positive power because we need to make this smaller number represent the big number that it actually does. If we're making a smaller number larger, we need to multiply it by a negative number, so that way we know that this 8 is actually not 8, but it's being represented by this decimal value here, and this negative 5 will tell us how many spaces we need to move it over. All right, so we're just going to do a couple examples with this really quick. All right, so once again, when we're writing scientific notation, it's given as a number between 1 inclusive and 10, and it's being multiplied by power 10. So remember, it's A times 10 to some power, where that number A has to be greater than or equal to 1 or less than 10. So it can't be a number that's 2 digits before the decimal place. All right, so if we want to write it in scientific notation, we're just going to do it the quick way here. We find our decimal point and we count how many spaces we need to move it over until we have a value that is less than 10 or greater than or equal to 1. So this will be 1, 2, 3, 4, 5, 6, 7. So we know it's 2.36 times 10 to the 7th, because since we're making a larger number smaller, it's going to give us a positive number, because we need to represent this in a way that if we multiplied it, this 2.36 would grow to give us this number here. And that's why we have to multiply it by its positive power. Or you can think about if you move your decimal place to the left, it's giving you a positive value. All right, and this other one, if we want to make this number, we find our decimal place. Now that we're counting it to the right, or we know we're going to make a smaller number larger, we know that this power that we're going to multiply is going to be negative. So we just count the decimal places. 1, 2, 3, 4, 5. All right, so if we stop there, that will give us 2.36. And this is going to be times 10 to the negative 5th power. All right, so that is whenever we're making a smaller number and appear to be larger, we need to multiply it by a negative value, so that way the reader knows that this is actually a very small number. For making a larger number to be represented by a smaller way, then that tells the reader that we need to multiply it by a positive. Or if we're moving it to the left, it's positive. If we're moving it to the right, it's negative. All right, then there's just one other example I want to go through with you, and that is going to be when we're given scientific notation to write out its original number. All right, so doing this first one, 2.57 times 10 to the 4th power. All right, so when we're doing this 2.57 times 10 to the 4th, this tells us how many decimal places we need to move it. And we know since it's positive that this number has to be larger, so we're going to move this to the right. So it's 1, 2, 3, 4. So that means that this has to have 2 more zeros added to it. So this is actually representing 25,700. All right, now here we want to move it, so it's saying 7.853 times 10 to the negative 3rd. So since we're multiplying it by a negative number, we know that this value actually represents a smaller number, so we need to move this to the left. So it's going to be 1, 2, 3, and we would add the 2 zeros, so it's 0.007853. All right, so that's how you can do this. Also, if you refer back to the chart that we were doing before, when we were doing 10 to the 0 power is equal to 1, 10 to the negative 1st is equal to 0.1. What we were doing as we were making our values negative, this decimal place was just moving to the left. So that's why this decimal place is moving to the left here. And when we did the numbers here, where we started with 10 to the 0 is equal to 1, and then we did 10 to the 1st is equal to 10, this decimal place, as we're multiplying it by a positive power, is moving over to the right to give us that larger number. All right, so that's what we're doing here. We're moving it to the right 4 spaces. All right, that is it for this video. I know it was a little bit longer than normal. I apologize for that, but that is it for this video.